and welcome, my internet friends, to Defeasible Reasoning, a podcast about things and security and stuff. And that's about as fine-tuned as we've got it at this point. We're broadcasting to you not live from the Grand Rapids Community College Center for Cybersecurity Studies Media Services building. I am joined today by Matt Carpenter, a principal researcher at Grimm. Is it Grimm Cyber these days, or is it just Grimm?
It's Grimm. Actually, the official name is different. Grimm's a DBA, but Grimm is it.
Gotcha. Just Grimm. And cool site.
We own Grimm.RIP.
Nice. I didn't realize .RIP was a thing.
Just became.
We were just whining about how using .com, .edu, .org domains get things bounced back to you quite a bit and scare most of the security products that exist in the world. I use a .ma address for things, and you'd be surprised how few people like an email from a .ma address gets to. Let me, as usual, introduce the third person in the room, executive producer / co-host, Noah Smith.
What's up?
There we go. What is a day in the life of a principal security researcher look like? What is your day job these days?
Which day?
Not today, because today you're doing the podcast thing, so that's probably not typical.
So I've been at the company about 5 years, and day in the life has changed every year, sometimes by the month, sometimes by the day. I'm going to compress a week into a day because it varies. What I try to make sure that I get to is plenty of technical playtime. Now I call it playtime, but it's billable work. It's good stuff, but I love it. It's enriching to me.
And what's an example of billable working? Your hardware, software, firmware, reverse engineering, radio stuff, vulnerability research. So can you give us a generic project? I don't want you to break any NDAs here, but like
yesterday, for example, I'm reverse engineering an Android app that relies heavily on Android native code. That is a portable library that also runs on OS X. It also runs on Windows.
Like one of those, we teach a course using this thing called Appcelerator that's like a JavaScript framework that'll cross-compile to all those things.
So this was written for Windows, and then they modified it to make an app. And what they did was they took all the disparate libraries that they have on their Windows system, including, and then wrapped in libc and a bunch of other libraries, and they made one portable library that's like crazy huge.
Oh, wow. So if there's a vulnerability in any of those libraries, they get to go back in, rebuild their library. But
it's one library.
It is. It is one library to rule them all.
80 megabyte library. It's crazy. But I've got a very large project of which I can only say pretty much that I'm reverse engineering a bunch of different components. There's a hardware component, and I get to choose which areas to focus on to get to the answers that I'm after. And in this case, the Android native library was the most easy.
Right, because I imagine if you have you compiled this Uber library a year ago, 8 months ago, I can just go find any of the public vulnerabilities in any of those sub-libraries and say, ha-ha, I have you now.
So when I think of reverse engineering, I'm imagining somebody finding a downed drone and then like taking it apart to understand how it works and maybe build it themselves. How would that apply to software? How would you reverse engineer software?
So reverse engineering is a concept that plays throughout the computer security realm, from the photons and electrons all the way up to large user interfaces on a Windows machine or a mega monitor. So with hardware, you take a look at what's actually on the board, or boards if they're connected together. And on the board, you may have chips that you can go research, a computer chip like an ARM chip or a Renesas. Sorry, I told you I wouldn't swear. And the traces that connect all the chips, there may be EEPROMs or flash chips, things that you may be able to pull data off of or modify data without even having to dig into how everything else works. You just poke onto this chip, pull it off, look at what the information is, and change it. Then you move up the scale a little bit to software or firmware reversing. So the code that actually gets put on these chips, it is called firmware. If it's looking at stuff that's running on your laptop or server, it's called software. It's all just code that's been compiled down to interface with something. So software reverse engineering takes two major paths. One path is reverse engineering a Windows binary or a Mac binary or a Linux binary or something that lives on some major operating system.
So like
QNX.
when I click on word.exe, that exe is a binary, and that's what you're reverse engineering.
Exactly. So your word.exe, your kernel 32 DLL, things that live in an operating system. The other path for firmware is called raw firmware, where firmware has been compiled. It is one application that has been compiled down for a specific chip, and the code that gets compiled in there actually knows how the chip works. And the chip may have a network interface connected to it, and that's on some port with these parameters. And so the firmware itself will configure that network adapter and then talk directly to the buffers that handle the things that the operating system masks from you, basically. So that's where I spend a lot of my time between those two things and the hardware side. Don't get me started on radio. I love radio.
We'll try not to. And right now, since the FCC is not actually doing their jobs at this point, I mean, if you wanted to screw around with radio frequencies, nobody's going to stop you. Literally zero regulation going on right now. So that sort of reversing work, Grimm is not just a West Michigan concern, right? Most of you guys have like offices in sort of the DC area corridor, Crystal City, where the big government contracts are, because there's only so much reverse engineering steel case needs done.
So Grimm started as a couple of intelligence community people came together saying, let's start a small company, because these big mega defense contractors, they do awesome work, but it kind of sucks to work with them, as any large multinational can cause. So started off with 3 intelligence community people, and we drew more. And so there's still a lot of ties into DoD intelligence. And so that's where the skill set was developed. Now I live here. Bryson, the founder of Grimm, said, I want you to lead the critical infrastructure embedded hacking team. And so I've been building out an exploitation team focused on embedded systems, critical infrastructure. My
critical infrastructure meaning like power grid and dams and
water and or
like
water
critical.
Yeah, everything that depends on computers and hardware type things. So we have another team that focuses on servers and laptop type stuff. So it's not that we don't have the skills, it's that this is where our focus is. So I've ended up hiring some very special unicorns that have embedded development engineering backgrounds that understand vulnerabilities and exploitation. So
because to do really quality reverse engineering work, it helps to have done first forward engineering work, so you kind of know what you're looking for
or looking at.
Right.
So I'll look at a disassembler and I can tell that this information is being pushed into this register here and this register here and that register there are being used to multiply something together. I can do all that. But if I've written C code specifically, and even more so if I've written C code for embedded systems.
Or for like this particular chip that we're trying to figure out what's going on or whatever.
Right.
Yeah.
Then I immediately can say, oh, wow, this chunk of code is doing this thing that I've already done myself when I've programmed. So.
Right. So you've like seen that process from the developer side and kind of have an idea of what to look for. Because when a computer compiles code down to something that when your software program compiles code down to something that the computer can use, it takes out all that useful human stuff like variable names and functions and all that jazz. So when you're looking at it after it's been reverse engineered, kind of a pain to try and figure out what is this loop doing over here, particularly if you like never bothered to write a loop that does that kind of stuff.
Sure. So I look for other people crazy like me where
this particular flavor of crazy.
I would prefer to look at disassembly. If you gave me source code and compiled code, I would look at the compiled code first. Huh. I find that far more telling. You can't lie to me. If you ever looked at the source code for the Linux kernel, you can tell C lies to you quite often. So the things that I get from the source code, though, is comments and variable names and things that allow me to take the logic that I'm looking at and put the thinking of the developers behind it.
Gotcha.
So sort of to what end do you reverse engineer these things? So is it to discover problems that might be like a company who has created something asks you to, can you reverse engineer this and make sure there's no problems? Or is it a company that's requesting, hey, we want to make something that's like this. Can you reverse engineer this so we can make something like that?
So Grimm has had two primary guiding stars since the very onset. One, make the world a better place. Two, be an attacker for everything that we can. So we use the attacker mindset and the reverse engineering skills to make the world a better place. Now, that may look like an automotive OEM coming to us saying, hey, hack our car. And we've done that many times. Now, what level? I mean, the next question is, what level of hacking do you want us to do? Do you want us to do some assessment of your design? Do you want us to tear apart your hardware, tear apart your firmware, things like that?
Gotcha.
And there are other purposes that make the world a better place that may be not in that direction.
It's kind of subjective too, what exactly it is to make the world a better place.
There's always going to be somebody who hates me.
So how did you get from into this business? Like, what got you here? It looked like I was perusing your CV, and at one point you were teaching for SANS way back in the day. Were you doing like the week long?
Yep.
I show up on Monday in a hotel and I stay there till Saturday afternoon. And
my dad worked for IBM. I had a computer when I was 7, programming when I was 8. Pissed off all my computer science instructors all through high school and college.
Are you from Grand Rapids?
I'm from Flint.
Okay.
That's my background. I've been programming and loving computers ever since I was able to even think about. Comp sci degree, took a job in engineering and instructor. And I was actually trained to teach Novell because Novell really put you through the ringer, and it was a great experience.
Oh, you mean to, I'm sorry, back when the Novell certifications were a thing, that kind of teach for Novell?
Yeah.
Oh, wow.
So teaching Novell, teaching Microsoft, and I moved very quickly into the network engineering roles. And then I took a job at Amway Corporation, doing a lot less stressful work and a lot of fun supporting global trade, and then moving into telecom, and then finally into their security department. In 2004, my manager said, I want you to go take a SANS course. And said, and I said,
was it in Grand Rapids?
No.
Okay.
They actually sent me to it.
Gotcha.
So
like that was what got me into security too, was a SANS course, and it was one of the ones that somebody was doing a boot camp in Grand Rapids.
Sure.
So that was like the thing that turned me on, and right around that time frame too.
So my thing was, I went to the boss and said, so there are 2 courses that are interesting. One is this telecom focused thing, AAA server, VPN, firewalls, which I'd been doing already professionally. And this other one, the hacker techniques, exploits, and incident handling course that
sounds like real fun.
Would be interesting. I think it'd be very beneficial. And he said, think outside the box. So what did I do? I went and
sounds like a good boss.
I got to meet Ed Scotus and take his hacker techniques course. Incident handling is actually the focus, but hacking to get the skills to do incident handling is basically how it rolls. So at that point, I had figured out that this capture the flag thing was a lot of fun, and I could throw exploits that take over computers and do a lot of fun things. And then the next year, I ended up thinking that I could do the DEF CON CTF, and well, that was a very, very different animal. But I decided, after giving up for about 6 hours, I decided, well, let's give it a try, and threw my weight into figuring out how to reverse engineer software binaries, which I thought was
like at DEF CON that morning. You're like, damn, let me get the
So they have a
DEF CON
pre-qualifiers. And my in-laws thought ahead and had already purchased Hacking the Art of Exploitation for me that Christmas before. So it was ripe. But I thought that type of stuff was for immortals. And so when I was able to throw my first remote binary exploit, that I had found the vulnerability, I had put together the exploit to take over the remote machine, it occurred to me that I had been selling myself short, and this was freaking amazing fun. And so ever since then, that's about 15 years ago now, ever since then, I have found great joy in helping other people cross that bridge, taking them from capable, but they won't let themselves think that they can, to showing them that they have no idea what they're capable of.
You know, it is easy to follow a checklist and, you know, and for like network penetration testing, they like run, you know, the tool and get reports back on which vulnerabilities exist and use the pre-canned exploits. But like when you are hitting that place where you are finding new things and doing new stuff that nobody's ever done before, it's an amazing place to be.
Well, I find that I'm going to dominate this. I'm sorry, I cut you off.
I don't have anything to say.
I find that there are two primary ways that people approach hacking or pen testing. And one is, how do I do this so that if anybody comes back and asks me to defend it or review what I've done, I'm making sure that I've done what other people might have done. And that
so you've checked all the boxes.
Basically. It's a fear-based approach, and it limits your success. I mean, you may do a systematic attack, but there's an internal thing spinning, keeping you from your full potential. The other one is, I'm going to go find out what I can find out and respond to that and periodically pull back and do my own process, basically. And if there's one thing that I found, there are so many people who are afraid to go outside and do their own process because they think that everybody else is doing it better, and they want to not be able to. They want to be able to say that they did it like Charlie Miller or Dino Dizovi or big names, amazing people. But they didn't think, oh, what would Ed Scotus do? Or what would so-and-so do? They thought, this stuff is right in front of me. Let's see what it wants. And they figure out from what they're dealing with, they get to make up their own minds.
Huh. So how do you deal with like the halting problem that goes along with that? Do you ever find that you can go down a blind alley and find out that it's just an alley, and it's not, the end result of where, this path you're taking is not, I found a new and interesting vulnerability, but I found, this software is actually not particularly vulnerable in this particular place. When do you back off and try another, turn in the dungeon?
So my wife says that I have a web thinking mind, and she says that she's a linear thinker. And so the conceptual things are tied together in a big graph with nodes and edges. But the short answer is I take notes. I take notes of my path. I take notes of what I'm thinking. As I take notes, as I'm going down, it's an internal dialogue only in a VI or in some text editor, where I'm typing out or I'm writing in a logbook things that might be interesting, things that I'm thinking about, because my brain is coming up with ideas that I don't have time to do. So I'll write down the stubs, and I'll choose the one I think is best, and I'll go down that thing, and periodically, maybe daily, maybe every other day or whatever, I'll reassess. I'll come back and say, how's it going? And I'll review my notes. I'll think, because I always forget. There's a metric ton of stuff that I forget in a project. So I'll come back to my notes. I'll find a different path that maybe makes me happy. And I'll say, I'm going to go distract myself over here while this one stews. And so in having multiple threads spinning, and by switching between them, I feel the most comfortable that I'm going to find the best path open up fastest.
Gotcha. So you sort of background a task, let your subconscious kind of stew on whatever's going on back there, and then the foreground, whatever else is going on.
It's a highly personal thing, though. If you asked several other people, they'd have their own thing.
It connects well to, I noticed your handle on LinkedIn is Curious with a K. Mm-hmm. I don't know if that was purposeful or not. I imagine it was. It wasn't just the random string of characters that they gave you. And curiosity seems so important, not just in this field, but across all. And I wonder how important you think curiosity is in this particular field, to have that curiosity to kind of go in different directions and think outside the box.
It's vital. It's vital. At some point, you can do deductive reasoning. You've got to bring inductive in at some point. And in order to be inductive and deductive in a meaningful fashion, you have to be curious. You have to wonder. I could spend the rest of my career reverse engineering this 86 meg binary that I'm hacking right now. But I'm curious, and I know that I'm not going to be able to do all of it, so I'll have to just kind of decide what things that I go poke at.
I agree that like a serious part of this whole business, I mean, not just like binary reversing and that sort of thing, but like the whole security thing writ large, there's so much like imposter syndrome if you talk to people, because it's an overwhelming and daunting place. how long do you figure you're going to spend? More importantly, like how long is your client going to pay you to dink around with their 86 meg travesty of a library?
Right.
And while doing that, you're not out learning, whatever the latest vulnerability is in other thing X or the, all that other stuff that's out there that you have to worry about.
Yeah, like this thread X, I've got 4 different articles left open in a web tabs to go research thread X because I just don't have the time. I want to focus on where I'm at.
Right, and what's paying mama's bills?
Well, sure,
that's important too. So one last question: if we touched on this a little bit in our email before the show, hacker culture, is it just a filthy hive of scum and villainy, where like we're a bunch of little boys who can't keep our stuff together, or do you think that there's like a big difference between red team types and blue team types?
Wow, that's a long discussion.
Sum it up to 10 minutes.
But to sum it up, so hacker culture, there's a lot of crap in there. There always will be.
Will there?
But yeah, sure.
All right.
But we're reducing the types and the impact of the crap. That's I think the best way that I can say that we're trying to approach. So sexism. And in hostile environments, we're working on that. We're self-policing and thumping down on jerks. But there's a large part of hacker culture, and it generates a lot of greatness and a little bit of cruft, or a lot of cruft. But it is the core of it is doubting my assumptions, not just accepting things for what they are, but pushing on them, questioning them. Fuzzing reality, fuzzing the
relationships between people,
laws, whatever. And that's where DEF CON can be an amazing creative place. And it can be some people.
Bunch of dude bros being jerks.
Well, you see, it attracts a lot of posers. The idea of miscreant draws a lot of people. So the level of knowledge at DEF CON is actually very small. But the idea of questioning everything, of discovering. It's the curiosity again playing out in mostly good ways when I'm around. At least that's what I see.
Are you selective about who you're around?
Yeah, there's douchey people that I'll ignore or move away from. But overall, again, I think that the DEF CON often is fairly self-policing.
And there's more to hacker culture than DEF CON.
Sure. But I think that it's the pinnacle of. It's the origin for a lot of hacker culture.
So here at GRCC, we have a Center for Cybersecurity Studies.
We do indeed.
But do you have any advice or suggestions to students who are getting started in this and when they're thinking about their career, getting started, just any kind of simple advice that they might want to think about as they're getting into this?
Sure. Allow your curiosity time. Play around. Get to know things. Don't necessarily stop when you think that it's too hard. Look for some way to make a pattern from the chaos. The second thing, and you may edit this out later, but I'm a Christian, and one of the things that I love in the Bible, it says, soberly assess yourself. Now that means don't think too highly of yourself. It also means don't let your self-doubt become the reality of who you are. And the only way that you can really do that well is by surrounding yourself with trusted individuals that you respect, who can give you feedback and ask them for feedback. Say, am I soberly assessing who I am, where I'm at? That can allow you to break through your own self-doubts into greatness. And the last thing, don't be afraid of wasting time. I know time and money are the essence of what we have as resources. And if you have a lot of time, you probably don't have a lot of money. If you have a lot of money, you probably don't have a lot of time. But don't worry about wasting time. When you're discovering, when you're curious, when you're learning, you're diving in, and that makes me happy and it makes me feel very powerful. And indeed, it has made me very powerful.
Cool.
It's a good place to end, I think. Thank you very much, Mr. Carpenter. I would love to have you back sometime.
Thank you.
To pick your brain even more.
Sounds great.
This has been yet another episode of Defeasible Reasoning, brought to you by Grand Rapids Community College. Thank you to our guest. Thank you to Noah. And thank you to you, the listener out there in podcast land. We'd like to think of us as maybe not your internet friends, but at least your internet pleasant acquaintances.
Write an iTunes review for us.
Drop the mic, literally. Defeasible Reasoning is produced at the Epic Studios of Grand Rapids Community College Media Technologies Department. Epically executive produced by Noah D. Smith and hosted by me, Drew Roseman.